Welcome to Spring LIB.
So here's a top view of the setup. Here we see that the bar is pivoted at this end and the bug sits here, and this is the table. So the bug jumps off perpendicular to the pivot point. We say this is the direction, and there are a few notations that we should remember. Now we're saying that A is defined as bug, like A as defined as the object bug, and B for the bar. So MB corresponds to the mass of the bar. Similarly, MA corresponds to the mass of the bug. And when the bug jumps this way, then there will be some angular speed or angular velocity on the opposite direction, and we mark that as omega b. Now, also we're given the length of the bar, which we call r here. So if we apply conservation of angular momentum here, we see that before collision, the angular momentum is zero because the system was at rest. But after the bug jumps, there will be some non-zero angular momentum, and we can calculate that using this expression, where ma times va is the linear momentum, and we multiply that by the radial vector, so that gives us the angular momentum. Since omega b is going in the opposite direction, so we put a negative sign after that, and then we put the angular momentum due to the pivot or due to the bar, which is ib times omega b, where ib is the moment of inertia for the bar. Now we see that since the bar is pivoted at one end, so ib will be 1/3 mbr squared. So from here, we'll equate these two things, before collision and after collision. And since this part is zero, so this whole thing should be equal to L1, which is equal to zero. So from there, we get omega b equals to 3ma va divided by mbr. So all we did here is we substituted IB by this expression and then solved for omega b. And using the given values, so we're already given MA, MB, R, and VA. So using the given values, we see omega b is 0.12 radians per second. So to review, omega b is the angular velocity after the bug jumps from the bar. So in part B, we need to find out the kinetic energy of the system. So before the bug jumps, the system was at rest, so the initial kinetic energy was zero. But the final kinetic energy will be the kinetic energy due to the bug jumping off. So the linear velocity of the bug is VA. So half mv squared is the kinetic energy of due to the bug jumps at a certain velocity. Then we have the rotational kinetic energy. This is because the bar starts rotating, which is half of IB times omega b squared. And we have already shown how to get IB and omega b. We already got omega b from the previous part. So if we put all the numbers, we see that the kinetic energy is 3.2 times 10 to the power minus 4 joules. And in part C, the source of energy is basically when the bug jumps, it pushes the bar, and because it pushes the bar, there is some work done by the bug on the system, and that work done is been converted to the kinetic energy. Thank you.